Hello everyone, welcome to Lecture 8, Discrete Probability. So what is probability? The probability of an event E is the quotient or a fraction of the number of desirable outcomes over the number of the total possible outcomes. So it's denoted at where the cardinality of E means the number of desirable outcomes and the cardinality of S means the number of the total possible outcomes. Here is called an event. So an event is an outcome or combinations of outcomes from an experiment. And an experiment is a process that uses an outcome. And S is called the sample space. Is the event consisting of all possible outcomes? So in this case, E is a subset of S, and S is a finite sample space. You can also have infinite sample space, but in our course, we're just going to cover the finite sample space. So E is the subset of S, for S is a finite sample space. So let's consider the following example to illustrate how to calculate the probability of an event. So suppose we have a normal 6-sided die, and we want to find the probability A of rolling a number greater than 2. So for this type of problem, the way to do that is to find the number of desirable outcomes, then the number of the total possible outcomes, then put that in fractions to calculate the probability. So in this case, the number of desirable outcomes is going to be rolling a number greater than 2. So the possibility is going to be 3, 4, 5, and 6. And therefore, the cardinality of A in this case is going to be equal to 4 because you have 4 different outcomes here. And the number of total possible outcome is going to be 1, 2, 3, 4, 5, and 6. And therefore, the cardinality of the sample space is going to be equal to 6. Then, when you calculate the probability of the event A in this case, going to be the cardinality of A divided by the cardinality of S equal to 4 divided by 6. Or if you can simplify, you can do 2 over 3. And when you use the calculator to calculate the decimal number, it is going to be equal to around 0.67 or 67% chance of rolling the die and getting the number of greater than 2. So we conclude that there is 67% chance of rolling a number greater than 2. So from these calculations, we're going to draw out some remarks. The first remark is that the probability will always be a fractions. And the probability is a real number between 0 and 1. For P is the probability. In terms of the percentage, you can write P is between 0% or 100%. Now let's move on to another example. So suppose a normal coin is flipped 10 times in a row and you want to find the probability E of getting exactly 3 heads. So again, similar to the last example, what we're trying to find is the number of desirable outcomes and the number of the total possible outcomes. In this case, you flip the coin 10 times in a row. So what is going to be a desirable outcome? So the desirable outcome is going to be getting exactly 3 heads. So the number of desirable outcomes so getting exactly 3 heads. So how could you calculate this number? You go back to the counting principle. You count how many of the sequences getting 3 heads. Again, you're going to flip the coin 10 times, and among the sequences you get exactly 3 heads. So this is the combinations problem, where n is equal to 10 and k is equal to 3 because you just care about exactly 3 heads and don't care about the order where the 3 heads occur. So again, this is the combination problem. Where n is equal to 10 and k is equal to 3. Therefore, the number of desirable outcomes is going to be, so let me call this the cardinality of E is equal to combinations of 10, 3 is equal to 10 factorial divided by 3 factorial times 10 minus 3 factorial, or this is 10 factorial divided by 3 factorial times 7 factorial, and this is going to be equal to 240 desirable outcomes of getting exactly 3 heads. Now, what about the total number of possible outcomes? Remember, you flip the coin 10 times. So here you are. There are 10 different slots. For the first slots, it's always going to be 2 choices of getting a tail or a head. So 2. For the second slot, the same thing. There's 2 choices, either head or tail. So 2 here, so on and so forth. Then you use multiplication principle to calculate the number of the total possible outcomes. And you're going to get the result to be 2 to the power 10. Now you can calculate the probability of getting exactly 3 heads. That is the probability of E equal to the cardinality of E divided by the cardinality of S. And you got 240 divided by 2 to the power 10. And using the calculator, you get that's going to be approximately equal to 0.23 or 23%. So you conclude that there is 23% chance of getting exactly 3 heads when flipping a coin 10 times in a row. So move on to the last example in this video. So I want to calculate the probability of getting the jackpot in a Powerball situation. So for the Powerball jackpot, you must correctly match 5 white balls chosen from 69 numbers from 1 to 69, and 1 red ball chosen from 26 numbers from 1 to 26. Since we don't care about the order on which the 5 balls appear, choosing 5 white balls going to be a combination problem. So in this case, we don't care about the order. So the number of desirable outcome is very simple, right? We want to get a jackpot, and there's only one desirable outcome for this particular scenario. So the number of desirable outcomes is going to be equal to 1. And the number of the total possible outcomes, we need to do a little bit of work here. So there's 2 things that we need to calculate. The first one is choosing 5 white balls, and the balls are chosen from 69 numbers from 1 to 69. So for the 5 white balls, because we don't care about the order on which the number occur, this is again the combinations problem, and this is equal to the combinations of 69, comma 5, or this is 69, choose 5, and you have 69 factorial divided by 5 factorial times 69 minus 5 factorial, and this is equal to 69 factorial divided by 5 factorial times 64 factorial, and this is equal to 11,238,513. So the outcomes for choosing white balls is going to be this number. Now, when you choose 1 red ball, it's still a combinations problem because we just choose one number out of the 26 number from 1 to 26. For 1 red ball, it's going to be the combinations of 26, 1 is equal to 26. Choose 1 out of that, and you get 26 factorial divided by 1 factorial times 26 minus 1 factorial. So 1 factorial is equal to 1. So you're going to get 26 factorial divided by 25 factorial, and this is equal to 26. And therefore, the number of the total possible outcomes is going to be, so the cardinality of S is going to be, you take 11,238,513 multiplied with 26, and you're going to get 292,201,338. So the probability of you getting a jackpot is going to be the cardinality of E divided by the cardinality of S, so 1 out of 292 million chances. So this is approximately equal to 3.4 times 10 to the negative 9. So the chance of you getting the Powerball jackpot is going to be very slim, almost impossible to get a jackpot. And so anytime you buy a ticket for the Powerball, make sure that you think about this particular problem and don't waste your money on that. Okay, so that's it for me. In the next video, we will continue with this particular discrete probability, but we dive a little bit deeper into the discrete probability theory.